Okay, there's 33 vertebrae in total. There's 7 in the cervical vertebrae, there's 12 in the thoracic vertebrae, 5 in the lumbar vertebrae, 5 in the sacrum, and 4 in the coccyx. Now, really the answers to, if we're asked to identify one vertebrae from each section, all the answers are really found in these 6 vertebrae. So we start with the first vertebrae, and it's C1. The correct anatomical name of C1 is called the atlas. It comes from the Greek god who held up the earth. So the atlas holds up, or is attached to the base of the skull, so holds up the skull. And you notice how it's different to all the other ones because it doesn't have a body. It's just got a ring of bones. But there's one characteristic which occurs on all these cervical vertebrae, which has got these 2 holes in the outside, and they're called the transverse foramen. So transverse meaning side, and foramen meaning holes. So it's got the ring of bones with no body, and the transverse foramen. Now the second vertebrae, or C2, is also called the axis. And it's got this different feature on it which isn't found on any of the others, and it's this little knob here sticking up here called the dens, or the odontoid process. Now notice as well, it's a cervical vertebrae, so it has got the transverse foramen, or the holes in the outsides, as they all do. But it's the only one with that dens. Now, as I mentioned, it's called the axis, and it gets that name because that dens, C1 fits on top of C2 like so, creating a little pivot joint at that dens. So the atlas rotates around its axis, around this dens. Now the next vertebrae is C3. Now it's really anywhere between C3 and C6. Now it could be any of those. The only difference between C3 and C6 is size. But I know it's C3 to C6 somewhere because it's got a couple of distinguishing features. Number one, it's still got these transverse foramen, or the side holes. But it's also got this split spinous process, or a bifid spinous process. So it's split at the tip. So it must be a C3 to C6. It's got transverse foramen and a bifid spinous process. Now, the next vertebrae here I look at, and it must be C7. Now, the other name for C7 is the vertebral prominence. It gets that name because it's the vertebrae at the base of your neck that sticks out a little bit more than all the others. Now, I know it must be C7 because it's definitely cervical, because it's got this transverse foramen still, or the side holes in the side. But it's got this spinous process that's not bifid, or not split at the tip. So it looks more like a thoracic in the spinous process. Can't be thoracic because it's got the transverse foramen. Now, what are all these transverse foramen for? Well, whenever you've got a hole through a bone, there's usually something running through it, nerves or blood vessels. Now, there's more holes through the cervical vertebrae because we've got a lot more nerves and blood vessels which are running up to our brain. Moving on to the next vertebrae, and it's a thoracic vertebrae. And the reason I know it's a thoracic vertebrae is not just because its shape, the body of the vertebrae looks more like a heart shape, but it's got this spinous process that projects back, sort of, it's pointy, and it sort of goes slightly down, or inferior. So it's got an inferior kind of direction, pointy spinous process. And it's also got these 2 flat surfaces sticking up. They've all got these facets, or flat connecting surfaces, but these ones are pointing kind of towards me, so posteriorly. And the ones on the bottom are pointing anteriorly, or towards the front. So superior articulating facets point posteriorly, inferior articulating facets point anteriorly. Another way of saying that would be they occur in the coronal plane. Now, if we take another thoracic vertebrae and I place it on top, the superior articulating facets of one vertebrae actually attach with the inferior articulating facets of the vertebrae above it, creating a little gliding plane joint, or zygapophyseal joint. Now the 2 bodies don't touch because in between the 2 bodies there's going to have a disc in here like so. So a vertebrae will touch each other in 2 ways. 1 at the zygapophyseal joint, or those facet joints, and 2 at the body between the vertebrae. Now, if a gliding plane joint can only glide past each other, it can't lift off in any way, it just kind of glides on past. The actual shape of the facets and the direction they face help us determine which movements occur at thoracic joints. So if I can't pull that a facet joint away from each other, that means I can't flex forward like that, or I can't extend, because notice when I do those actions, the facet joints break. Can't do that. So what it can do is it can just glide laterally. And that helps us to know that in the thoracic, between our thoracic vertebrae, the movements that occur here is largely lateral flexion. So if I look at the final vertebrae here, it's a lumbar vertebrae. Now, I know it's a lumbar vertebrae for a couple of reasons. The first and obvious reason is it's bigger than all the others, but putting size aside, it's got a body that's shaped like a bean. I've also got here a spinous process which is projecting more posteriorly, and it's quite blunt, unlike the thoracic vertebrae which was pointy. The spinous process on the lumbar is blunt. Also, I've got these facet joints, or facets, or superior articulating facets, which are pointing towards each other, and the inferior ones which point away. So it's more like on an oblique type angle. So if these are now pointing towards and away from each other, another way of saying that is that these facets occur in the sagittal plane. Now that means that if it's occurring in the sagittal plane and a facet joint can't break each other, it will only allow movements in the sagittal plane. So the movements that occur at the lumbar vertebrae are largely flexion and extension.